Hello, and thank you for having me. It's really great to have this opportunity to speak today. I'm going to share a story of some tech huddles and an architecture decision record that I call the persistence of microservices. And along the way, I'll be showing some really beautiful images from the Museum of Modern Art. I want to encourage everyone also to support the arts, especially in this day. My name is Paula Paul. I'm a distinguished engineer with Grayshore. We refer to ourselves as a little band of pirates consulting group that has a lot of fun. We do a lot of re-platforming of older applications and infrastructure to cloud. You can reach me on social media, and I do blog on Medium, Simply Technology, so please reach out. How did this all start? Well, in these re-platforming to microservices, the question always comes up. I've done this a few times across all the major clouds, and no disservice to IBM, but I always say it's Google, AWS, Microsoft. I'm actually looking forward to adding IBM to that. But the question always comes up, if data falls within a microservice boundary and nobody else consumes it, is it really data? And what you see here is Van Gogh's The Olive Trees, where if a tree falls in the forest. So please enjoy this beautiful imagery that accompanies our technical tale. Also, for some context, difference between refactoring versus replatforming. And I'm sure many of you are in this situation if you're pursuing microservices. Refactoring is well-known, common definition. It's restructuring code and adding tests in an existing architecture. For example, if I'm refactoring code in a layered monolith, I'm still in a layered monolith. There are techniques such as strangler pattern, that I think of as techniques that are the beginning steps of replatforming, which is porting existing logic or adding tests within a new architecture to achieve a new architecture or evolve to a new architecture. And it's really difficult, again, to refactor your way into a new architecture. Why replatform? Replatforming is often needed to enable scale and resilience or adopt new capabilities for SaaS or cloud. And the image here is Edward Munch, The Scream, which if you've ever been through a replatforming or a reimagining of legacy code, the people who have worked on that code and supported it for many years often have this kind of expression that we're very good at getting them into the brave new world and making things easier for them. Also, layered monolith versus brokered services. This is our current adventure. I've been on more than a few of these because layered monoliths are very common. If you've worked on any systems that are 15, 20, 25 years old, it's very common to have a layered monolith where you have an experience layer, business logic, and some kind of facade over persistence. And commonly, again, in the last 25 years, it's relational databases. Code is deployed to servers, data is deployed to the database management system. State is typically shared, so the components or the concerns of the monolith are all pointing right back at that relational database. A lot of times there's shared tables, stored procedures and such, and the way that you scale it is to scale up. Not an uncommon situation. I personally, not to brag about age, I was at IBM in the days where we were gleefully anticipating the event of doing real-time two-phase commit. So ever since then, it's really been largely relational implementations of state when I think of persistent state. And now we have so many more options that are globally scalable and so forth. This leads us into much more rich experiences with brokered microservices, hard to say, where each service can individually encapsulate their own data or state. Those services expose interfaces, whether they're request response like REST or event-based interfaces, and state is not shared. Here we have a nice layered monolith that is Picasso's apple. So in this adventure of replatforming a layered monolith to brokered services, what are some of the considerations? First, we want to really understand the boundaries of context of the different aspects of the application or the capability. Data encapsulation is very important. Well-defined interfaces, and then always considerations of brownfield versus greenfield. I mentioned earlier the strangle pattern. which may be something you'd pursue if you wanted to do brownfield integration of a new service into an existing monolith, versus sometimes there is a necessity to do greenfield porting of existing intent or logic into new services, perhaps because they can't be containerized easily or put into serverless functions. Here we have Lisa Strausfeld's sugar interface for the EXO laptop, one laptop for everyone, or one per child. So I love this. It's showing nice bounded context and some data encapsulation. Oops, I'm sorry, one more. So getting into our tech huddle, we've deployed a few services now and looking for more persistent state and options for persistent state. The team wanted to know what architecture principles we need to align to, and then kind of go into implementation details, design, and certainly data encapsulation is important. CAP theorem, in case you're not familiar, it's also been with us a long time. It's you can have at least two of these three, and sometimes you're lucky if you can have one of consistency, availability, and partition tolerance. So if the network goes down, how reliable is your state and your system? So I think these are especially important when you are dealing with these microservice implementations, because you are by definition a distributed system. And then simple by default is my favorite, one of my favorite architecture principles. Some people like to say KISS or keep it simple, but I like to say we should only introduce complexity when there is measurable value to the complexity. But simple is in the eyes of the beholder, because if you say, well, what is simple? It's simple because I know how to do it, relational implementation. It's simple because it's designed for global scale, performance, and distribution. Maybe it addresses some of my CAP theorem concerns. Or is it just simple for the developers, but maybe not so simple for the people who do our infrastructure as code and deploy the SaaS services that provide it? This one, the image is voluntary prisoners of architecture, which I feel like sometimes, and it's Rem Koolhaas and team. The actual debate. I love tech huddle debates, even though they're over Zoom now. All the developers come in and it's like, everybody gets to pick their own service. I want MySQL, I want Azure SQL database, I want Cosmos DB. We, in this particular adventure, are replatforming to Azure. We want it to be all cloud native, no dependencies on physical data centers or infrastructure. So it was really interesting because developers, especially when you have a microservice responsible for its own destiny, the developers like to make the call. But then I'm hearing all this and also watching our DevOps team start to sweat a little bit, because all of these different approaches or different SaaS services come with their own deployment complexities, maybe different kinds of considerations for scale, for security, and so forth. So also, I found there were some things that we might need to unlearn. The developers might say, I definitely want something that has a good ORM, or entity framework support, and I definitely want something that has database migrations so I can version my schema. And so it's, what is simple by default? And versioning was actually one of the things that we kind of had to discuss for unlearning, because when you are responsible for your state, it's an internal concern, not an external concern. And even further, in cloud, there's so many temptations, and shared state could almost happen accidentally. For example, Azure Synapse Analytics can plug right into any of these persistence stores to get direct real-time analytics, but then you have to ask, well, what does Azure Synapse Analytics expect that schema to be? And that's directly accessing my state. So now I might have to introduce versioning, or I might have to introduce some additional complexity around moving things to a data lake or whatnot. So it's very easy in the broad availability of SaaS services to forget that we want to have data encapsulation. This is a Dolly picture of St. Anthony holding off those cloud services that want to get directly at his state, the temptation of St. Anthony. So no images for these two slides, a lot of words. I will apologize for all the words, but this is actually text from the architecture decision record we landed on just last week, reiterating that services, microservices, must be fully responsible for managing their own state. We had earlier adopted Redis Cache in Azure for ephemeral state, and this ADR addressed more long-term persistence. We also documented that microservices that encapsulate state are expected to be bounded to single-purpose specific context. State is really not expected or intended to be complex or shared. That's a tough one because if you've been in like OLTP, very complex environments and layered monoliths, it can really take you some time to unwind the complexity and try to get state down to simple. Transactions, especially financial transactions, there's really many times only a small set of data elements that are the transactional elements. So it's really an interesting design goal to have state become as simple as possible. And then that allows us to say that service state is considered an internal concern, not an external dependency. And we don't necessarily need to version internal concerns. That discussion was, well, you have function signatures within your code. Do you version those or do you just refactor? So it was a little bit of a learning exercise to understand why we really wanted to version schema. And it does come down to a lot of times that there are external dependencies on your physical state schema, and you don't really want that. And I apologize for that. So finally, the architecture decision record itself for persistence, this is the big reveal. Service or microservice implementation should consider Cosmos DB as a default choice for long-term persistence. It was really an interesting journey there because everybody was, oh, this is NoSQL, and what about my ACID transactions and such? But if we say our services so far, and we have a few, don't really require complex state. The NoSQL approach does really support everything we've got so far. And then we have this goal now of making it the default choice, unless there is a specific reason to introduce more complexity. And this gives us a way to move forward so that we can implement, iterate, and learn and adjust. The other thing is that Cosmos DB is a bit of a simpler choice for our infrastructure as code folks. It's one service to deploy, manage, and then it's already enabled for global scale and distribution, so it takes care of some of our CAP theorem concerns. And then last but not least, the services may actually keep their state in one instance of Cosmos DB or more, but the services don't care. They can enforce encapsulation using resource tokens. So my service uses my resource tokens to get to my information. I can't get to yours, and then we don't really even care as service developers, whether it's 1 or 7 different instances or deployments of Cosmos DB, we have our encapsulation. So this was a really interesting journey for us. This is Matt Keegan's How Do You Document a City? I recommend ADRs. And then last but not least, let me leave you with some resources. If you are not using ADRs or architecture decision records, highly recommended. A great resource, and I've even referred to this in the deck here with the different architecture types, is evolutionary architecture. If you're interested in Cosmos DB, it is kind of an interesting database or data persistence capability. It's got drivers for different implementations like Mongo, Gremlin, Cassandra, a SQL driver that supports entity framework, so it can make 80% of our needs very attainable with some simplicity. And then finally, please donate to the arts, and thank you for your time as we view Dieter Roth's literature sausage, Search for a New World. Thank you very much.